So just for the confirmation to every participant, I will run that poll again because we have to include.
But we have not heard him, so don't run the poll now.
No, no, no.
Please.
I will rerun. I will rerun. That's what I'm saying. Because meanwhile I run that poll, so I will rerun that poll. So let him go ahead with his presentation. But then again, I will run that poll.
Yes. Yeah. Should I start?
Yeah, please.
Yeah. Thank you. Thank you. So I'm sure that you're able to see the presentation. This is the electrostatic disinfection unit which was developed during the lockdown in the COVID pandemic, and we of course did a lot of things like touchless lift and foot operated, optical operated, tap hand sanitizers. But this is one machine which the basic concept we took it from CSIR CSIO, and then we customized and re-engineered the project to suit the requirements that would crop up inside places like could be airports, could be railway stations, hospitals. And the major advantage of this disinfection machine is that when you build a sprayer, it normally makes droplets which are of the size of between 100 microns to 200 microns. And this disinfection machine breaks up these droplets due to electrostatic charge, further breaks it up into very, very small particles, which is the nominal size is between 10 to 20 microns. Why this is done is that most of the disinfection chemicals, they are very harmful chemicals. We want to kill the viruses, bacteria and all that, but at the same time, we want to make sure that we are using minimum amount of disinfection. So this machine is built with that kind of purpose. And when we started building this disinfection machine, there were a lot of challenges which came up. Of course, we got the basic document and the basic sort of know-how from CSIR, but then very limited facilities were available during the time, and we brought compressors out because it's an air assisted kind of a device. That means you have a disinfectant which is kept in a small tank, and then the air pulls the liquid and develops a spray in a small chamber which is called the nozzle. So we used a very portable kind of a compressor which was much smaller than what is normally used, and a smaller capacity because we wanted to reduce weight. At the same time, we remodeled the nozzle to make sure that we were using lesser disinfectant. So what was the nominal drawings which were originally of 110 ml per minute consumption, we have brought it down to somewhere around 40 ml per minute. In addition, while we were working on this disinfection machine, we did a lot of trials, in the sense that you measure because all these droplets are charged droplets. So you measure the charge that the droplet is carrying. So it's an indirect method of knowing the droplet size. So there is a charge to mass ratio which has to be monitored. So we try to improve the charge to mass ratio in this particular machine. And also we implemented certain things like we measured the amount of current which you see when we are it's a unit which gives between 1000 to 1500 volts for doing an induction charging of the water droplets. So while you are giving this kind of voltages there, you have to be very careful about safety. We made sure that all the elements which were used were rated for 4 kV and above. However, at the same time, we also developed our own circuit which monitors the current, and the nominal current the circuit takes is around 6 to 7 microamperes. We monitored that at around 1 milliampere, the circuit should trip. And at the same time, by any means, if a person touches the high voltage, which is basically not accessible, it is inside insulated body, but still if he touches, the voltage should drop across some series resistance and the person should not get a shock. So all these features were built into the machine. We did a lot of trials, in the sense that we had to develop, see what was the head of the water that was required, how much high the tank had to be kept with respect to how we were using it, so that we get an optimum performance. So we sort of get a spraying distance of around roughly around 2.4 meters, and a very low consumption. We probably in our hospital, which is a small hospital, we probably one tank suffices the entire hospital. We did a lot of trials with materials also, because some of the disinfections that disinfection chemicals that we use are highly corrosive. So based on the different trials that we did with sample materials, we changed the tank to a stainless steel tank. We remodeled the whole thing, and in fact we are going ahead, and we are going for a patent for the protection and the circuit of current monitoring, which enables to tripping of the machine in case there is a person who touches it or there is some other short circuit. We also in this in the process of developing this, we realized, the amount of the air pressure has a very critical role to play. So we introduced a filter and regulator. Filter because we wanted the air to be dry. There are a lot of uh, oil which comes into the air inside the compressor, so we didn't want that to go into the nozzle, because the sizes are very small. Yeah, it'll actually get clogged. So we had these are introductions we were done, because we were doing the re-engineering. So these were the introductions we were done. We had a filter, we had a regulator. So the user gets a option of having a regulated performance and seeing what would suit his application. So applications could be different. You have a tall ceiling, so your throw would be a requirement. If you are very close by, probably then spread would be a requirement. The beauty, what happens is the water droplets which actually come out of this machine, they are negatively charged. So normally it is found that the furniture or other things that you have, they're normally positively charged, so they attract these small droplets. And once the droplet goes to a particular location, the next time this droplet which is there at the location is going to repel the next droplet and make sure that it spreads to another location. So this is a unit which really reduces the disinfectant utilization in a very big way, and make sure that we are able to cover a larger portion. And yeah, so these were all the trials. And in fact the whole process of developing, of course, the little bit of the beautification and other things took a few more days. We started on the 28th of March, and on the 5th of April we had the prototype ready. We had all the design parameters frozen, and thereafter we went, and we have these machines have been supplied uh, uh, to various places. Like we have one machine in the Ministry of Commerce, we have one machine in Department of Heavy Industries, we have one machine at the New Delhi railway station, and various hospitals, AIMS also. So and we have a lot of we have supplied machines to PGCIL, to in fact CSIR also ordered a machine on us for their IHBT at Palampur. So it was really challenging in terms of development of the product, because we had a lot of constraints with terms, not just with terms of the manpower, we had constraints in terms of the materials. So initially we were trying to look at the resources which could be readily available, because trying to make 10 or 15 of them, we didn't have suppliers in the market who would be able to supply them, because their factories were shut down. So under these constraints, the product that we have come out with is indeed very innovative. It is more than the product for the company, it is a product for the country, and can be used at various locations across, and it is already in use in many places. You would see that we have sort of made a general comparison of what a conventional and electrostatic disinfection does, and I think I've explained most of it. I would try to keep the time as minimum as possible. um, in addition, yeah, just closing it, sir. So what we have talked about, it is uniformity. There's a lot larger distribution, reduced consumption of disinfectant, reduced droplet size, reduced time for disinfection, of course, and it also goes into hard to reach areas because of the charge on the water droplet, and it's of course very budget friendly. These are the various uses, and we already put it in use on several locations. This is the team, myself, Naveen Kaul, and our general managers, in fact our head and our other team members were closely involved. Many a times they would look at it from a user's perspective. They would say, yeah, if it's happening, how it is happening? how can we verify that it is happening, or how to make it a little more useful, or how a user can actually find out, whether it's working or whether it's not working. So all those annotations and the LED displays were brought in with those inputs from our team. And basically, I also like to show you a small share which our BHEL hospital chief medical officer uh, has has done, and it would I think it's a small video where he would talk about how he has seen the utilization of the product, and also our general manager.
Mr. Kumar, we are running over time actually. So please,
Yeah.
already there was some miscommunication. So better you can please,
No, do you want me to close it?
if it is possible.
Yeah, fine. It's okay. But this was some of the feedback from our the hospital which has been using it extensively. We have a lot of
Yeah.
COVID.
Yeah.
Yeah, this is a very timely, innovative step that you have taken, and it's proven its
Thank you so much.
efficacy. But there are two parts of it. One is that the way you use it, and you prove that it reduces the
In
disinfection.
the what I can do, sir, is that in the presentation you can actually see the spray being done. So I would
No,
just
that could be
it's okay.
visualized now, but possible
Okay,
that we
fine,
can
fine.
understand. Your presentation
Okay,
was very
fine.
lucid and clear. We can visualize this situation. That the thing is
We
that there are two aspects to this.
kept
One,
it short. We were new. We knew that. Yeah,
there
yeah.
is some problem.
The suggestions, inputs, how we can make it better or make it more useful.
See, it
Yeah.
all depends. Like
Am I
you
audible,
have
sir?
one. Yeah, you are audible. Am I audible?
Yes,
Yeah,
yes,
yes.
you are.
Yes.
Okay. So that the question is that you see now you have a system at place and a device in place, which is very useful and reduces
Sir,
the droplet size. Am I audible?
Yes,
Am
sir.
I
Yes, sir.
audible?
Yes, 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 sir.
It's reduces the.
I'm unable to hear you, sir.
Uh,
Can you please repeat, sir? I could not hear.
I said that you see this is a very timely, innovative step you have taken at the time of Corona crisis. Am I audible?
Yes, sir.
Yeah,
You
yeah,
are.
yeah, yeah, yeah.
Now this the best part of it that this has reduces the use of food disinfectants, right?
Yeah.
And which presumably is also has a side effect if excessive use. Is that right? That's what you're.
You're right. You're right.
So now this is you have been doing it by reducing the droplet size and spreading it in a more micro way. All right. Now, one time spraying, how long it lasts and how much time it has its own life, and when you have to repeat it again, and
Sir, yeah.
yeah, tell me. Okay, I will answer. Then I'll follow up the question. Okay.
Sir, actually, this is a unit which is independent of the disinfectant.
Mhm.
So different people use different kind of disinfectants depending on their use. Like a hospital would use a 1% hypochlorite. Maybe in an office they would use 0.5%. There are people who use Lysol, mixture of Lysol as written on the bottle. As a
Right.
disinfectant. So that property is dependent on not on the machine. It is dependent on the disinfectant.
Correct. Right.
So that's what I'm asking, that since there is a variance in the chemical composition of different disinfectants, is our machine
Yeah.
is flexible enough to take cognizance of these chemical compositions?
Yes, sir. Yes, sir. Actually, what happens is, sir, if you look at it from a very basic perspective, you would see that it's basically, if it was distilled water, it would never charge. So it's the impurity in the water. What they do is they mix Lysol and water. So impurities in the water allow the droplets to get charged. Now, when you have a ring in which with close tolerance you are passing 1500 volts, what happens is the water droplets, which the droplet is just from little ahead of the ring. So the water droplets of 200 microns, they develop surface charge, and the
Right.
surface charge breaks it up into it breaks the surface tension, and it
Yeah.
breaks it up into smaller particles. That is what happens, sir. And it
No, but
happens across the board for all the disinfectants. Life of the
The-
disinfectant, we really don't know. It depends on the
the, the essential base being the water,
yeah.
then the water density and the character of the water, depending on the temperature and the area, also change.
Yeah.
So the machine of yours will
Yeah.
accommodate such fluctuations.
Yes, sir. Yes, sir. Yes, sir.
Okay, sir. Thank you, everyone. Well,
I just want to ask a question. Is it now marketed, or
Yes,
you are
ma'am.
still on?
Yes, ma'am. We have already marketed. We have supplied to IHBT, which is
Not like that. Now, is it supply on order or is it
yes, yes.
marketed?
These are supplied on order only. I'm talking about orders. We already have orders
That's
from
okay. That's
NTPC,
okay.
PGC.
No, that's okay. That's okay.
thank you,
He's
Mr.
selling the
Kumar.
product.
Thank
Okay,
you.
great
But you
product.
are
Thank
planning
you.
to market it as a general product or no?
Yes, yes, ma'am. It is
Mass
already being
production.
marketed.
So
Yes,
basically,
yes.
I'm
Yeah.
talking about mass production.
Yeah, we are planning to do it,
you.
but
Yeah.
we will
What
be
madam is
we will be